Hi everyone, welcome to our presentation. Our presentation is about real-time anomaly detection business process for industrial equipment using Internet of Things and unsupervised machine learning algorithms. My name is Emrullah Gültekin from Yıldız Teknik Üniversitesi, Türkiye. In this presentation, we will provide an overview of our work, including the fundamental concepts, research problem, proposed methodology, prototype application, and conclusion. In proposed methodology, we will outline our proposed methodology for achieving real-time anomaly detection in industrial equipment. And in prototype application, we will showcase our prototype application that embodies the proposed methodology. And in conclusion, finally, we will conclude the presentation by summarizing our key findings and contributions. The essential equipment determines production efficiency, especially in the industrial sector. A malfunction or a failure in this equipment can lead to production stoppage and significant financial losses. And it is possible to monitor the status of these pieces of equipment and avoid faulty stations with minor damage or even prevent them before they occur. And IoT systems can be used to monitor such systems and to provide predictive maintenance. The fundamental concepts which we use are IoT, Contiki NG, CUJA, data provenance, predictive maintenance, and data stream clustering. The IoT is a technological concept in every aspect of our lives. McKinsey's report says the annual economic impact of IoT in 2025 will be in the range of 2.7 to 6.2 trillion USD. And 41% of this market is healthcare services, and 33% is the industry. By 2030, organization can generate value using data generated by 8 billion people and 25 billion connected devices. Data provenance, the word provenance originates from the French term, meaning to come from. Data provenance is the ability to trace the origin of data and identify how it has been altered or transformed throughout its life cycle. And the data provenance helps to ensure predictive maintenance in IoT systems. Contiki NG is a new generation open source operating system for resource-constrained devices. There are a few setup types: Docker image, vagrant image, or native toolchain installation. We use Docker image for our setup. And CUJA Network Simulator is a simulator in Contiki NG. We use this simulator for generating the anomalies present a deviation from a common rule, a model, a system behavior, or a set of traditional elements. And predictive maintenance addresses the detection of anomalies that may result in high cost system downtime or even lead to potentially fatal errors. In the realm of real-time anomaly detection and predictive maintenance, data stream clustering plays a vital role in uncovering patterns and identifying anomalies within the continuous flow of sensor data from industrial equipment. In our study, in our research, we use MOA, Massive Online Analysis Platform, a framework for data stream clustering. And we use three of algorithm from MOA. One of them is clustering. Clustering is a popular data system clustering algorithm designed to handle large and evolving data streams. It employs a microcluster-based approach to efficiently summarize and represent the data stream. And clustering is another significant algorithm within the MOA framework that focuses on data stream clustering. It utilizes a hierarchical clustering approach to organize the data into a tree-like structure. And StreamKM or StreamK-means is a widely used algorithm for data stream clustering that leverages the popular K-means clustering technique. Our research questions are: what is a good software architecture design of an unsupervised machine learning-based business process for detecting anomalies which can lead to failures of industrial machines on the streaming data coming from IoT devices? Can clustering algorithms be used effectively for real-time anomaly detection in streaming IoT data? How can we perform real-time anomaly detection on streaming unlabeled data in IoT system? And which real-time unsupervised machine learning algorithms are best suited for detecting anomalies in streaming IoT data? Proposed methodology, we aim to detect the errors of large industrial machines without causing any damage to the machines by using real-time unsupervised machine learning methods on unlabeled data. And we worked on provenance data to enable anomaly detection using big data processing technologies. We proposed a real-time anomaly detection business process for predictive maintenance of industrial equipment. This is our proposed business process. And here we aim to detect and intervene in the errors of large industrial machines without causing any damage to the machines by using real-time unsupervised machine learning methods on unlabeled data. As you can see in figure, sensor environment data and sensor device data are first obtained from IoT devices equipped with a mobile operating system such as Contiki NG operating system. Then streaming data undergoes various operations and is clustered using clustering algorithms within a streaming machine learning library, such as the MOA framework. And domain-specific features such as temperature, pressure differentials, humidity sensor values, flow sensor values, level sensor values, and vibration pattern can be used to extract information specific to the IoT system being monitored. And these features can be used to identify anomalies that are unique to the system or the environment it is operating in. In addition to all this data, metadata information related to specific features of IoT devices can be added. Information such as battery level, memory status, CPU status, sensors, ID, and sensor type can also be extracted. And here are some real-time clustering algorithms that can be used for anomaly detection using streaming-based machine learning library. The choice of clustering algorithm will depend on the nature of the data and the requirements of the anomaly detection task. And it is important to carefully evaluate the performance of different clustering algorithms and tune their parameters to achieve the best results. And in the proposed software architecture, we indicate that any streaming-based machine learning library that can support streaming-based clustering algorithms can be utilized. And in the prototype implementation of the proposed architecture, we will use MOA framework for the streaming machine learning library to be able to cluster real-time data and detect anomalies in the running observation data of this industrial equipment. And as I said, we use clustering, and StreamKM algorithms for identifying outliers. This is proposed data process and analysis process. As you can see here, we get the data from IoT devices. Here we have a RPL border router, which enables us to connect the internet. And we get the data. We use mass stream machine learning library. We have a data offset, 35% of data. Then we give 15% of data every time, and we evaluate the data, and we calculate the outlier counts of the data. For our prototype application, we use Contiki NG, next generation operating system for IoT devices, Puja as network simulator, Node.js to represent the data as REST APIs, Docker for containers, and PostgreSQL for storing the data into the database. MOA framework for streaming clustering, and Java programming language, and Eclipse as a tool for programming. And these are our applications versions. Dataset. We use NASA turbofan jet engine dataset. This dataset which we use has more than 6,000 running observation. All the data ends with a system failure, and it has 26 columns, engine number, cycle, sensor data, etc. Result, actually, our starting point here is as follows. Machines should exhibit certain anomalies before experiencing failures. So if we can detect an increase in the number of the anomalies as we approach the occurrence of the failure, we can predict and take preventive measures based on these anomaly situations. As you can see here, the figure on the left indicates the clustering algorithm. The figure in the middle represents the clustering algorithm, and the figure on the right side shows the StreamKM clustering algorithm. And we observed that as the number of outliers in the running observation data increases, the industrial equipment is more likely to fail. Such real-time anomaly detection system can prevent the system from failures by keeping track of the increasing anomaly behaviors. And for StreamKM, actually the class stream and class tree don't need a cluster count, but StreamKM utilizes the Cummins algorithm. Here, it is important to provide the correct value for the number of clusters K. Instead of randomly assigning this value, we aim to find the optimal key value for our data. To achieve this, we use the silhouette method, and we determine that the optimal key value for this dataset is 3. So we use 3 as key. And here you can see the results again. As you can see, we give here 35% offset data, then we give 15% of data every time, and you can see the cluster count, outlier number, and we measure. As you can see, we use the V-measure method to measure the quality of clustering results. It can be seen that the clustering performance with all three algorithms is of high quality according to the V-measure values. These results indicate that algorithms using IoT and machine learning technologies may be more suitable for real-time anomaly detection in industrial equipment. Conclusion, we propose a business process, we provide a prototype implementation, we conduct an experimental study of the prototype implementation, we use the NASA turbofan jet engine dataset, we calculate the number of outliers over the time, and we use unsupervised machine learning technique, and we report the results. In future studies, we can increase the number of machine learning algorithms, and we can use deep learning approaches, and we can evaluate with different data sets. These are references which we used. Thank you for your attention.